share the screen. I think it's this one. And then we're gonna go ahead and start streaming. How long have I been streaming? That's weird. Maybe did I hit the shortcut? I may have hit the shortcut. Recording says it is streaming, so I'm not gonna worry about that. Let me see. Oh, that's so strange. I guess I hit the shortcut. Okay. Let's see. That looks good. Let's see what it is. Let's go here. Let me check one more time. Okay. Nope. Don't do that. Let's go like this. Okay. All right, that looks good. I think the only thing I'm just trying to get this to display properly. So have it like this. Ooh, like this. There we go. All right, let's go like this. All right, yeah. So no major announcements other than just make sure your Pearson is up to date as soon as possible. Everything is going to be over fairly quickly. This is the end of week 11 for you guys. So yeah, we have week 12. I think we have like 14 weeks. We're going to be done before Thanksgiving. So when we go for the Thanksgiving break, we're already going to have taken our final exam. So it's going to be over in the blink of an eye. Okay. And also, just as a warning, the closer we get to the final exam, like that time period, the slower Pearson more than likely is going to go. It tends to slow down and because everybody like nationwide is online trying to get their final stuff submitted, especially with everybody being online. Usually it slows down around like midterms and finals. So that's why I tried to like make things as available as soon as possible. Let's take some time to go. What is this? Today's what, Tuesday? Man, I'll be forgetting what day it is. So we're at the top of week 11. Let's take some time to go through this section. I'll be monitoring the chat, so if you have questions, just feel free to use the chat or unmute yourself. But yeah, let's try to focus and like get through the material. Okay, and yeah, we'll do it like that. And I'll try to save a little bit of time towards the end for like Q&A for questions and answers. Write down your questions or put them in the chat and just kind of allow me to kind of share. Let me move this out of the way. Okay. So we have polynomial and rational functions. So this is section 2.3, dividing polynomials and the rational zero test. So some objectives here. We want to learn how to use the division algorithm, use the remainder and factor theorems, and use the rational zero test. So say we have a polynomial d of x, and say it's a factor of a polynomial f of x. We say that this d of x is a factor of f of x if there's a polynomial q of x such that f of x equals d times q, right? So basically we say f divided by d, we end up with q is the quotient or the answer, right? So this whole notion, it comes out of just like how we divide numbers, right? A lot of those properties hold. And we'll see it in action momentarily. So again, the dividend is this guy. The divisor, so we say the dividend divided by the divisor, we get this answer plus a remainder, right? Again, let's back up. The dividend divided by the divisor, we get the quotient, which is our answer, plus a remainder, right? So, and these are all polynomials in this context. Let me check and see what that is. All right, let's let them in. Let me give them attendance credit first, because I know if I don't give them attendance credit, when I go to do it, I'm like, who was that again? It was this person. All right. Yeah, honestly, I mean, as long as you just check in every time we have a class session, beyond that, I don't really make a big deal about everything else. And then get your assignments in, you know, to me, it don't get no much better than that. Like, it really don't. I know it's a little bit of a struggle because it's math. You're not as, I don't want to kind of launch into all that stuff, but yeah. So, yeah, so let's see this in action. I feel like this would be easier to see if we do it in action. So we're actually using long division and synthetic division to find the quotient and remainder when that dividend, let me see, is that right? Yeah, that dividend is divided by that divisor. So basically when this guy is divided by this guy, right? So the first one we're going to see is polynomial long division. Let me do this and change my view. Okay. And let's do this. All right. So if we're going to do polynomial long division, so we have this x plus 2 divided into, we have 2x to the 4 plus x cubed minus 16x squared. Notice the exponents are going 4, 3, 2, and it skipped over the power of 1, so we need a placeholder. We need to make sure to include x to the power of 1, and then plus 18. All right, so every exponent has to be accounted for. Okay. So then when we do polynomial long division, we say the first divided by the first. All right. So if we say 2x to the 4 divided by x, I think we get 2x cubed, right? 2x cubed. So next, going in this direction, we want to multiply. So we're going to say 2x cubed distributed into this guy. If we distribute the 2x cubed, we get 2x to the 4 plus 4x cubed, right? Just like in regular long division, we would subtract on this line. We still subtract, and so we need to distribute a negative. So this is going to be negative, and this is going to be negative. If we do this, this adds to 0. 1 minus 4 is negative 3x cubed, and then this term just comes down, and we're ready. Now we just repeat the process. Give me just a moment to check and see who a brother that is. Let's go like this. All right. So then we're going to let him in. Right here. Okay. Let's go. Cool beans. Okay. And can we get you to move out of the way? You're kind of like in my way. Let's just, can you go somewhere out of the way? Okay. Well, we'll just let you be there for now. Okay. Maybe if I click over here. Okay, there we go. All right, so now we repeat the process. So we're gonna say this first term, divided by the first term. So negative 3x cubed divided by x is gonna be negative 3x squared. And then again, when we go in this direction, we multiply. So we're going to distribute that negative 3x squared. And we're going to get negative 3x cubed minus 6x squared. And again, we distribute our negative because we're subtracting. So it changes both of these signs. This first term adds to 0. Negative 16 plus 6 is going to be negative 10x squared. Okay? And then the next term just comes down. Again, we got to make sure to use our placeholders. Every exponent has to be accounted for, right? Now we just repeat the process. We keep repeating the process until we get to the end. So we're going to say this divided by x, right? It gives us a negative 10x, right? And I'm intentionally lining up my exponents with the exponent below. Like this is a 3, I lined it up with this 3. This 2, I lined it up with this. This power of 1, I lined up here. So then once I get my answer here, the next one, I know that's one way to know that you're done, right? So now that we got the negative 10 in this direction, we multiply. So we're going to get negative 10x squared minus 20x, and then we subtract, so we have to change both the signs. So this one becomes positive. We're distributing a negative. It's causing the signs to flip there. This adds to 0. This adds up to 20x, and this 18 comes down. Okay. So then this should be the last one. 20 divided by x ends up just being 20. And now we multiply, so we get 20x and 40, and distribute our negative. This becomes negative, this becomes negative. This adds to 0. That's going to be a negative 22. This is our remainder. Okay. So let's see what was the question. Use long division. Okay. So then the result ends up being, copy, paste, all of this minus, what was the original, x plus 2? X plus 2 under 22, right? The remainder, we'll put it over the divisor. Okay? So when we do polynomial long division, we finish with this result. Now, another technique that we have is called synthetic division. With synthetic division, what we do, we take the coefficients of our original polynomial. So in this case, the coefficients are, we start with the proposed 0. So because we're dividing by x plus 2, the proposed 0 could be, is going to be negative 2, right? So when we do synthetic division, negative 2 is going to sit in our chair, and now we take the coefficients of the original polynomial. We're going to have 2, 1, negative 16. We still have our placeholder of 0, and then we have 18. Okay, I think I have enough space here to do it. Okay, so now synthetic division is done in the following way. The first one just comes down. That's going to be this, and then on the diagonal we multiply. So negative 2 times 2 ends up being negative 4. Vertically we add, so that adds up to negative 3. Diagonal we multiply, and then we add, we multiply, we add, we multiply, and this is our remainder. Right? Notice we still had our placeholder, and so since we started with the degree 4 polynomial, this is called the depressed equation, and we finished with the degree 3. It always drops by 1 degree every time we do it. So this is going to be 2x cubed minus 3x squared minus 10x plus 20. Okay. So notice we get the same result, and that negative 22 is our remainder. So it goes over the original divisor. We should have the same thing. Okay. All right. Let's look at the view. Okay. So here's the type version of long division. Okay. Everything, and it looks like they did everything exactly the same way that we did it. And then synthetic division. Okay. Let's see the time. 25 until 3:15. So if a polynomial function is divided by x minus a, then the remainder is going to be f of a, right? So if we divide a polynomial by x minus a, the remainder is going to be f of a. This is called the remainder theorem. We can use this in both directions. Let's see this in action. We're asked to find the remainder when this polynomial is divided by x minus 1. So our proposed 0 in this case is going to be 1. So if we want the remainder, all we have to do is evaluate f of 1, right? So first I'm going to rewrite f of x, but I'm going to replace each x with a blank parenthesis. So we're going to get 2x to the 5th minus 4x cubed plus 5x squared minus 7x plus 2. Right? And again, in this case, our x is going to be 1. So a 1 goes into all of these blank parentheses. Okay? So then we get 2 minus 4 plus 5 minus 7 plus 2. So notice that 2 plus 2 is 4, minus 4 is 0, 5 minus 7 ends up being negative 2. So that's the remainder. And we can confirm that this is actually the case by synthetic division. So let's just do synthetic division to confirm. Okay. So if we're going to do synthetic division, again, 1 goes in the chair. The coefficients, let me see. We have 2, -4. Nope. We skipped over x to the power of 4, right? So we need a placeholder. 5, 4, 3. So now we have 5, -7, and 2. Okay. So again, the first one just comes down. That's this. Whenever we go vertical with this, we add. On the diagonal, we multiply. So then we get 2, 2, 2, -2, -2, 3, 3. What is that? -4, -4. And then they add it to -2. So we showed how f of that quote-unquote 0 gave an answer, and the answer ended up being our remainder as well, right? So that's the remainder theorem. And yeah, that confirms what we did. So let f of x be this. Now we're asked to find f of -3. So now we could plug in -3 and get our result, or we can use the remainder theorem in reverse. So if we want to evaluate this at f of 3, we can do synthetic division with the -3 in the chair, right? Let's see. So we have this -3. The coefficients, we have 1, 3, -5, 8, 75. Let me make sure my exponents are good. 4, 3, 2, 1, 0. I got 5. 1, 2, 3, 4, 5. Okay, we're good. So, again, for synthetic division, the first one just comes down. Then we get this. -3 times 1 is -3. We add to 0, 0, -5, 15, 23. What is that? 69? -69. And then we get what? 6. So our claim is that if we do f of -3, the answer should be 6. Okay? So we can confirm this. I'm going to put this in my calculator really quickly since we have a virtual one that we can use. Yeah, it's looking good. It's looking healthy. Reload and refresh. Come on. Okay, that looks okay. All right. All right, so let's go to our y equals. We're going to go to x to the 4 plus 3x to the power of 3 minus 5x squared plus 8x plus 75. Okay? I'm going to quit. I'm going to go to variables, y variables, 1 and 1. I'm just calling on the function that I just typed in. And I pretty much do this like almost every class. Well, a lot of classes. Not every class, but a lot of classes. So then when x is -3, the answer should be 6. Okay? So this example, we saw the remainder theorem in both directions. Okay? We might finish this one. Okay, let me see. Let's see. We'll do polynomial long division. Let me think. There are times when... Oh, polynomial long division? Yeah, okay. So there are times when we can't do synthetic division. We can only do synthetic division because we're dividing by like a binomial in the form of like x minus some number, right? But what if it were like x squared plus 3x plus 7? Then we can't do polynomial. We can't do synthetic division. You know, so you definitely want to practice with both because there are times when we don't have the luxury of using synthetic division. But I agree with you. Like whenever we do have synthetic division at our disposal, it's so much easier. It's so fast and smooth and swift and clean. It's like, yes. But we don't always have the luxury of using synthetic division. So you definitely want to be ready to use both. I like that commentary, though. I like that observation. But yeah, it's not that straightforward. So that's why we kind of go over this stuff. Okay. let's keep it moving. So next is we have the factor theorem. All right, it says a polynomial f of x has x minus a as a factor if and only if the remainder is 0, or f of a equals 0, right? So again, it's a factor if the remainder is 0, okay? So we said we're given that 2 is a 0 of this polynomial. We're asked to solve this polynomial equation. So we have a polynomial. We're given one of the zeros. We essentially asked to find all the zeros. Okay, so let's do this. Let's go like here. I think that's right. Let's do this like this. Okay. So let's take some notes here. I need some more space. I got to clear up this desk. I feel like I'm running like a chicken with a steak most of the time. Okay. Some southern sayings for you. Okay. Let's see. What do we have? Okay, let's write down what we have. So we have this f of x equals 3x cubed plus 2x squared minus 19x plus 6, right? So let's confirm that 2 is indeed one of the zeros, right? So if we want to confirm that 2 is a 0, we put 2 into our chair, and then we do synthetic division. So we have 3, 2, 1, 0, so 3, 2, negative 19, and 6, right? So then if we do synthetic division, again, the 3 comes down. That's going to be a 6. 6 plus 2 is 8. 8 times 2 is 16. Negative 3, negative 6. And indeed, we get our remainder of 0. So we get our desirable 0. Right? So we can confirm that 2 is indeed a 0. So now, if we started with a degree 3 polynomial, at this stage, we now have a degree 2. This is called the depressed equation. So this is going to be 3x squared plus 8x minus 3, right? So at this stage, the original polynomial is now factored into, we have x minus 2, again, times 3x squared plus 8x minus 3. And again, we're solving this equal to 0. So let's factor that trinomial, right? If we want to factor that trinomial, we're looking for two numbers that multiply to give us negative 9 and add to give us 8. And I think we get those two numbers off the bat. It's going to be negative 1 and 9. So what we're going to do, we're going to rewrite this negative 8, this green negative 8, using 1 and negative 9. But I'm gonna factor this using the box method. Let me see. So the box method kind of goes like this. And I kind of got this from students of the past, and they also have this demo on YouTube. Okay, so this is just the box method for factoring trinomials. In the upper left-hand corner goes the leading term, which is this. In this case, it's going to be the 3x squared. The bottom right is our constant, which is negative 3. And then again, that green 8, we're going to break it into the two numbers we just found. We said what? Negative 1x and a positive 9x, right? Okay. So then if we look at the two on top, what do the two on top have in common? We can factor out an x from both of those terms. What about the two on the bottom? We can factor out 3. What about the two on the left? We have 3x. And the two on the right, we can factor out a negative 1, right? So now our claim is that the above line factors into x minus 2. We have this 3x minus 1. And we have this x plus 3. Okay? And it still equals 0. And again, we can check. If we FOIL this out, we should get this guy here. All right? 3 times 1 is 3x squared. 3 times 3 is 9, minus 1 is 8. And then negative 1 times 3 is negative 3. Okay, so that checks out. So now we use what's called the zero factor property. When things multiply to give us 0, basically set each thing to 0 and solve. If we do this, we get x equals, we have a 2, positive 1/3, and a negative 3. So our claim is that these are this is the solution. To that equation, the above equation. Okay. So let's see. So now we want to check and confirm that the result that we got is correct, right? So we're going to go to y equals and clear. We got 3x cubed plus 2x squared minus 19x plus 6. Okay. So now let's plug in these values. I'm just going to call on the function I just typed in. So when x is 2, we should get 0. When x is 1/3, we should get 0. When x is -3, we should get 0. All right, so we confirmed these results, and they look good. And all is right with the world. And so it is. Okay. So let's hop back over here. Let me check the time. Oh, wow. Okay, we got a solid 20 minutes, maybe like 19. Let's take advantage of that. And actually, I think we could finish out this section. If we finish this section today, we can take Thursday as a study session. We could go ahead by week, but I'd rather keep the rhythm. Our rhythm is pretty good. We can take Thursday as a study session to just answer questions, homework questions, and things of that nature. Okay, so we confirmed that the remainder from the 2, we confirmed that 2 was indeed a 0. And then we did factoring. Now, we just did factoring a trinomial. We also could have used quadratic formula here. We also could have done completing the square to factor this quadratic, right? So given a quadratic, if it's solvable, we can always use either quadratic formula or completing the square to solve it. You know, there's several correct ways to go about this. It's not only one correct way. All right. So this example, it says the combined petroleum consumption C in quads by a group of the most economically developed countries in the world during 96 to 2011 can be modeled by this function, right? Where x equals 0 represents 1996, 1 is 97, and so on. The model indicates that C of 5, what's our x again? The years. So that should be what, 2001? The model indicates that quads of petroleum were consumed between 2001 and 2011, when the model indicates that 238 quads of petroleum were used. Okay, so this tells us, this model tells us the consumption of petroleum for any given year, and we want to know another year where 238 quads were used. So all we do is set the equation equal to 238 and then solve it, right? Okay, let's do it. So let's get some space like this, seamless. This looks good. Okay. All right, so this one is pretty straightforward. It looks intimidating because of all the decimals, but if you think about it, it's not too bad. We got the 0.021 x cubed minus 0.973 x squared, 11.347. I feel like there's supposed to be an x there. I'm pretty sure it's missing an x. 11.347. It is missing an x. Okay. So there's supposed to be an x here. And it's missing from here. That's okay. And then we're going to say plus 202,965, right? And we want this to be equal to 238, right? Let me get all this on one line. And expand it back. All right. So let's just set it equal to 0, and I think instead of using the quadratic, I mean, we can use a quadratic formula. I think quadratic formula would probably be the simplest. Oh, actually, no, we can't use a quadratic because this is a cubic. Okay, let me try again. Hang on. We might have to do. Oh, we're given one of the zeros, right? So if we plug in 5, that's going to be one of our zeros. So we might have to do synthetic division.